So today we're going to be talking about sea breezes, what they are, what causes them, and what their impacts are. So to do that, we'll look at this scenario here. So say you've got a nice piece of beachfront property right here along the Atlantic Ocean. We have the ocean here, and then obviously your house, which is right along the coast here. So the day starts off looking very sunny and clear, not too many clouds in the sky, and a very gentle breeze but not too severe. So you begin to wonder though, as the day progresses you notice some clouds forming and even a few showers and thunderstorms begin to strike. So basically you're wondering what causes this change in weather from the initially sunny and pleasant conditions to the dreary and rainy conditions. So the answer to this question is sea breezes. So the first thing that we'll analyze is the heating patterns of the land and the water. So obviously the sun's rays are striking both the land and the water equally. However, the difference comes when you look at how this energy is absorbed into the land and the water. So some of the radiation that strikes the land bounces back into the atmosphere through what is known as albedo. However, the majority of it goes right into the earth and is absorbed and thus causes it to heat. The opposite of this occurs with the sea, because you have a greater transmissivity, so most of these waves pass right on through and the energy is not absorbed into the ocean. Now some of the rays are absorbed into the ocean, however the majority of this energy is required to evaporate the water, so thus this energy is effectively lost through latent heat of evaporation. So this heating difference basically produces a warmer land surface than a water surface during the daytime hours, thus creating a higher concentration of warm air above the land and a higher concentration of cool air above the water. Okay, so now we'll take a look at another drawing here. We have our same scenario. So as I mentioned, we had a lot of warm air above the land and cool air above the water. And as we all know, warm air is less dense and thus becomes buoyant and rises upwards. So we have rising warm air here, and then over the ocean surface we have cool air that tends to sink and remain closer to the ocean surface. So when we have a lot of air molecules concentrated in one location, this is what we know as a high pressure air parcel. So we have high pressure above the ocean surface here, and we also have high pressure at the upper latitudes above the land here. And the counter of this is when we have a little amount of air molecules, so we have low pressure here and low pressure right above the land. And the main reason that winds are produced is by flowing along the pressure gradient in order to establish an equilibrium, in order to balance out the concentration of air molecules. So since we have such steep pressure gradients here, we have the air flowing from high to low, and then high to low going from the sea to the land at the lower elevations. And this right here is what we know as our sea breeze. So now you might be wondering, where does all this rain come from, and as the day is transformed from sunny to overcast? So the answer to this is this perpetuates throughout the day. You have rising warm air that continues to rise, and basically as this air rises, a lot of the water vapor in the atmosphere begins to condense as it cools and clouds are formed. And when we have a lot of clouds forming, eventually there's going to be precipitation. So during the daytime hours, as long as we have this unequal heating, this perpetuates throughout the day and you're going to see rain throughout the afternoon. However, during the nighttime, the opposite occurs and most of the rain happens over the sea because the sea is warmer and the land is cooler. So now that we've taken a look at the general principles behind sea breezes, we're going to basically look at some factors that might affect their direction as they approach the shoreline. So in order to do that, we're going to take a look at an aerial view of the ocean surface. So say that's the coastline there, and then we have our ocean on this side. and then here's your house. So basically the first factor that impacts the direction of the sea breeze is what is known as the Coriolis effect. So I'll draw a little diagram of Earth here. It's obviously rotating counterclockwise about its axis, and then we have the equator here. So take for an example, say you're on a merry-go-round and you decide to throw a ball off. So obviously the ball is going to have a straight line of projectile motion. However, from your perspective, it's going to look like the ball is actually turning in the direction of the merry-go-round, even though it actually is not. And the same thing occurs when we have Earth rotating and winds blowing in a straight line. They appear to curve inwards toward the equator. So this is noticed when we have sea breezes. These breezes appear to curve inwards toward the shoreline as they approach it, even though they're actually going in a straight line. Now the second factor that is actually going to change the direction of the winds is due to geographical features. So say we have a little bit of a mountain range right along the shore here. Winds obviously can't go directly through this, so they're forced to redirect. And a lot of times this results in the very oblique bending of winds or the rising of winds so they can go over the mountaintops. So some of the wind might bend to the left, some might bend to the right, and a lot of this wind is just going to go straight up, producing more clouds and precipitation over your area. So these two factors cause winds to bend an average of about 45 to 90 degrees from perpendicular to the shoreline, which is a very significant amount. So now the last thing that we have to look at with regard to sea breezes is their impacts. And obviously the first and foremost of these impacts is going to be producing significant rain and thunderstorms along the shorelines. And this continues during the afternoon hours and tends to be more extreme when we have greater temperature differences. So if you live anywhere along the Gulf of Mexico or the southeastern United States, sea breezes are going to have more extreme effects than if we're talking about the body of water being, say, the Great Lakes. So all of the factors, or all of the impacts of sea breezes are obviously prevalent and relevant to the people who live along the shore. So it's going to affect things such as water sports, activities that involve the water. Also, they're going to affect markets that are impacted by the winds along the shore, such as trading and shipping. So basically, in summary, the main cause of sea breezes is that pressure gradient. And that pressure gradient, as we recall, is formed by the unequal heating of the land and the water. And this is due again to the fact that land absorbs more heat than water. So basically, that's sea breezes for you.